Welcome to this session within our AI Foundations series. Today, we will delve into a concept that is often overlooked but absolutely vital for understanding how large language models operate: tokenization. Before we can explore how an AI reasons or creates, we must first understand how it perceives the very data we provide. Today, we bridge the gap between human language and machine logic. Tokenization: how AI reads language. When you interact with a model like Claude or GPT, it might seem like the machine understands your words instantly. However, under the hood, the model does not see letters or words the way we do. It sees a sequence of building blocks. Understanding these blocks is the key to mastering AI efficiency, cost management, and system limits. At its core, tokenization is the primary method of data ingestion for LLMs. It is the process of converting raw, messy human text into discrete, numbered units called tokens. It is crucial to realize that models do not read strings. Instead, every segment of text is assigned a unique numerical ID. This is the first, indispensable step in the natural language processing pipeline, serving as the interface between human symbolism and the mathematical layers of a neural network. Modern tokenizers typically utilize a method called subword splitting. For instance, a word like investigating might be broken down into invest, agate, and ing. Why is this necessary? It allows the model to handle messy language. By recognizing prefixes, suffixes, and roots, the system remains robust even when faced with typos, new slang, or technical terms it has never seen as a whole before. This allows the model to generalize from known fragments to unknown entities. Why not just use a traditional dictionary? Because language is infinite. New words, names, and acronyms appear every day. A fixed vocabulary of whole words would be impossibly large and computationally expensive to manage. By using subwords as universal building blocks, we can limit the model's vocabulary to a manageable size, typically between 50,000 and 100,000 tokens. These tokens act like Lego bricks. With a limited set of pieces, you can construct any sentence in existence. Following the decomposition, every token is linked to a specific value in a high-dimensional index. This prepares the data for the next stage, embeddings. We must understand that predicting the next token, the core task of any AI, is a purely statistical probability calculation. Tokenization standardizes the flow of text so that these trillions of calculations can be performed efficiently across massive datasets. For practical application, one rule of thumb is essential: the three-quarter rule. On average, one token represents about 3/4 of a word in standard English text. This means 1,000 tokens cover roughly 750 words, about the length of a standard academic essay. This metric is vital for evaluating information density and system capacity, though efficiency varies. While English is quite streamlined, code or non-Western languages often require significantly more tokens for the same amount of information. In the agent economy, tokens are the primary currency. Almost all commercial AI providers charge for their services per token, usually distinguishing between input and output tokens. If you understand how tokenization works, you can craft more efficient prompts and significantly reduce operational costs. Large documents or long chat histories consume tokens quickly, making token management a critical skill for scaling AI applications in a business environment. Another critical concept is the context window. This is the model's working memory, which is also measured in tokens. Everything, your prompt, the chat history, and any uploaded files must fit within this window. Once the limit is reached, the model begins to forget earlier information. Furthermore, models often suffer from the lost in the middle phenomenon, where information in the center of a large token stack is ignored in favor of the beginning or the end. Finally, consider the immense flexibility of this system. A modern tokenizer effortlessly handles rare proper names, emojis, and special characters through recursive decomposition. It breaks unknown terms down further and further until it finds fragments it recognizes. This stability across different formats and universal support for various writing systems make tokenization the robust foundation for global AI communication. In conclusion, tokens are the atoms of AI language processing. They form the indispensable bridge between human expression and machine calculation. By mastering the concept of tokenization, you move beyond being a casual user and begin to understand the actual mechanics of intelligence. Thank you for your attention, and I look forward to seeing you in the next module.